Right, let's do question 6b1. There are 20 trees in a box, 10 are chocolates, and 10 are marshmallows. Nelson randomly selects 2 trees without replacement. Draw a tree diagram. Draw a tree diagram showing all possible outcomes. Right, what is a tree diagram when it comes to probabilities? This is a graphical representation that will assist us in solving probability problems. Okay, this is a graphical representation that will assist us to what? To solve probability problems. Let's just discuss that before we continue with our question. Right, I will use two events, which is tossing the first coin, okay, and tossing the second coin. Remember, these events can be happening consecutively, meaning one after the other, or simultaneously at the same time. So we have coin, the first coin and second coin, or you say coin A and coin B. Okay, so the events may be happening consecutively or simultaneously. So how do we represent such in a tree diagram? So a tree diagram, the branches represent what? The outcomes of the events. Right. So now we have the first event, which is coin, the first coin. So from the first coin, what outcomes can you get? What are the possible outcomes? So you can get heads or tails. So we represent those using the branches. So like this. So we have the branch here, which is the heads or the tails. You see that we have two branches and we have two possible outcomes, heads or tails. Right. And then now, what do we do with the outcomes of the second event, which is the second coin? We are saying that if we got heads from the first coin, then it means we'll get what? From the second coin, we'll get what? Heads or tails still. So if the first coin we got heads, the second coin will be heads or tails. You see that? So these are the outcomes for the second coin. If we got tails from the first coin, if we got tails from the first coin, then we'll get heads or tails from the second coin. You see that? So we have represented our probability, or sorry, our outcomes on the tree diagram. Just one more thing left. We have to write the probabilities of each outcome. Where do we write them? On top of the branches, okay? Just on the branches. So the probability of, if let's look at the first coin, the probability of getting heads is 1 over 2. You see that? So the probability of getting heads there is 1 over 2. And then the probability of getting tails, 1 over 2. Okay, I want you to take note of this. If you add these probabilities, what do you get? What is half plus half? Is 1. If you add the probabilities of the branches, you'll get 1. Okay, let's go to the second coin. If now the probability for heads there is also half, the probability for tails there is also half. Again, if you check here, if you say you're adding the outcomes there, you must get 1. Okay, right. And then if the first coin we got tails, second coin can get heads or tails. Again, we have half them, and then the probabilities are what? They add up to 1. This is very, very important. Okay, you can get in the examination, they say we have, let's say what? This is milk. This is, let's say tea or something. Okay, and then the say probability of getting milk is 0.75. What is the probability of getting tea? You must be able to get this because these must add up to 1. So you just say 1 minus 0.5, it will give you 0.25 there. You see that? That is very, very important. Right, now I think we've discussed everything about the tree diagram. Remember, there's question 6b2 where we're going to talk about how we find the probabilities using the tree diagram. This question is about drawing a tree diagram. Okay, I just want to end there here. And then now let's go back to our question. All right, there are 20 trees in a box. 10 are chocolates and 10 are marshmallows. Nelson randomly selects 2 trees without replacement. There are 2 things which are very important here. Okay, we'll go back to that. Draw a tree diagram showing all possible outcomes. So now, 1, select 2 trees. So the selection can be done simultaneously at the same time or consecutively, meaning one after the other. So it means, but now it's without replacement, meaning that if the first one is picked, then it's not put back. Right, there are 20 trees altogether in the box. So if the first one is picked, then when you're picking the second one, it means that there won't be 20 of them. There will be 19 trees now. You see that? So these 2 statements are very, very important. Now draw a tree diagram showing all possible outcomes. So we have, let's use C for chocolates and M for marshmallows. Okay, right. So we have, let's say, marshmallows. The first treat can be a marshmallow or a chocolate. You see that? And then what are the probabilities? What is the probability of picking a marshmallow here? There are 10 of them out of 20. So the probability is 10 out of 20. And then what's the probability of picking chocolate? There are 10 chocolates out of 20. Again, so it's 10 out of 20. You see that? And then we have, if the first treat was a marshmallow, then the second treat can be a marshmallow or chocolate, isn't it? So marshmallow or chocolate. You see that? And then now, if the first treat was a marshmallow, how many marshmallows would be left? Originally, there were 10. If now the first treat was a marshmallow, how many marshmallows would be left? It means 9, isn't it? And then the total number of treats is no longer 20, it's now 19. So there'll be 9 out of 19 here, right? And then if the first treat was a marshmallow, how many chocolates will be left? 10, isn't it? 10. But now 10 out of what? Because we've picked a marshmallow here. So it will be 10 out of 19 because remember, the trees are not replaced, are not put back into the box. So is 10, the chocolates will be still 10 out of 19. Okay, right. And then if the first treat we picked a chocolate, then the second treat can be a marshmallow or chocolate. Right, remember to write your outcomes at the end of the branches. Or chocolate here, okay? Right, and then now if the first treat was a chocolate, then the marshmallow will be still 10 of them. But now the total number of treats in the box will be 19, isn't it? So it's 10 out of 19. And then if the first treat was chocolate, now there will be how many chocolates left? 9, isn't it? 9 out of 19. We're done. This is our tree diagram. But now also you can also include this part where it shows that this one is going to be marshmallow. It means you can pick 2 marshmallows. And then this one can be a marshmallow and a chocolate. The first one being marshmallow, the second one being chocolate. And then this one can be chocolate, marshmallow. The first one being chocolate, the second one being marshmallow. Or you can have chocolate. You see that? You can also include that part. And then remember, this was about what? Drawing a tree diagram, right? In our next question, 6b2, we're going to be calculating our probabilities using this tree diagram, okay? Right, we're going to discuss more in that particular question, but now let's end this one here. We'll meet for question 6b2.